ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. I am Dr. Shivkumar, Assistant Professor of Physics. In this video session, I'll be talking about how to solve the numerical problems on the topic rigid body dynamics. So, of course, the learning objectives to solve the numerical problems based on various concepts which are being discussed in rigid body dynamics chapter. So, to start with, the first problem, calculate the moment of inertia of a thin uniform disk of mass 5 kg and radius 0.1 meter, rotating about an axis passing through its center and perpendicular to its plane. First, let us try to write down the given data. The radius of the thin uniform disk is given. It is 0.1 meter. So from that we can understand that it's a circular disk, and m is equal to 5 kg, that is mass of the circular disk is 5 kg. So mass is given, radius is given, and we are supposed to calculate the moment of inertia of the disk about an axis passing through its center and perpendicular to its plane. And we all know that the moment of inertia of the thin disk or thin circular disk about an axis passing through its center and perpendicular to its plane is given by I is equal to mr square divided by 2, where m is mass of the disk and r is radius of the disk. So both mass and radius are in SI units, so therefore you can directly substitute that. So mass is 5 into radius is 0.1 meter, so therefore 5 into 0.1 whole square divided by 2. So 0.1, if you square it, it becomes 0.01. 0.01 into 5 gives us 0.05. If you divide it by 2, you can use a calci for this. Divide by 2, you will get 0.025 kg meter square as the moment of inertia of a thin circular disk. The next, second problem, find the radius of gyration of a circular disk of mass 0.1 kg and radius 0.05 meter about an axis through its center of gravity and perpendicular to its plane. Again, it's a circular disk. The mass is given as 0.1 kg and radius is 0.05 meter. The radius of gyration of the circular disk about an axis through its center and perpendicular to its plane is given by k is equal to r divided by square root of 2. R is equal to 0.05 divided by square root of 2. So if you divide 0.05 by root 2, you will get 0.0354 meter as the answer. So that is the radius of gyration of the circular disk about an axis passing through the center of gravity and perpendicular to its plane. So now the moment of inertia of the disk about the same axis is given by I is equal to mr square by 2. Again substitute for mass and radius. Mass is 0.1, radius is 0.05. Therefore 0.1 into 0.05 whole square divided by 2 equal to 0.000125 kg meter square. Suppose if you shift the decimal point by 4 digits to the right, you can write the same answer as 1.25 into 10 raised to minus 4 kg meter square. Next, the third problem, a thin circular disk of mass 0.5 kg and radius 0.1 meter is making 60 revolutions per second about an axis passing through its center and perpendicular to its plane. Calculate its kinetic energy. We all know that the kinetic energy of a circular disk or in general any rigid body is given by E is equal to half I omega square, where I is the moment of inertia and omega is the angular velocity. Here the given data, r is given as 0.1 meter and m, the mass of the disk, is given as 0.5 kg, and n, the number of revolutions or rotations are given 60 revolutions per minute. So convert this into per second. That is, if you divide it by 60, you will get 1 revolutions per second. So this is only n. So using the value of n, you can calculate the angular velocity omega as 2 pi into n, where 2 into pi into n is nothing but 1 revolution per second. So therefore, you will get omega as 2 pi radian per second, or else you can substitute the value of pi in that and calculate 2 into 3.142. Next, the moment of inertia of the circular disc about an axis through its center and perpendicular to its plane is given by I is equal to mr square by 2, m is 0.5 and radius is 0.1 square divided by 2. So if you simplify it and calculate using a calculator, you will get the answer as 0.0025 kg meter square. And then the kinetic energy of the disk about the axis of rotation is given by E is equal to I omega square by 2 or half I omega square. So I is 0.0025 into omega is 2 pi, that is 2 into 3.142 whole square divided by 2. So if you simplify it, you will get the energy or kinetic energy of rotation as 0.04936 joules, or else you can shift 3 decimal points to the right, you will get E is equal to 49.36 into 10 power minus 3 joules. Next, fourth problem, a circular disc of mass 10 kg, diameter 10 centimeter, makes 240 revolutions per minute. Calculate the moment of inertia and kinetic energy of the disc about an axis passing through its center and perpendicular to its plane. So this problem is similar to what we have solved in previously. So that is R is given as 10 centimeter. Therefore, the diameter is 10 centimeter. Therefore, radius is equal to 10 by 2 equal to 0.05 meter. And then mass is given as 10 kg. And number of rotations are 240 revolutions per minute. So if you convert it into seconds, you will get 4 revolutions per second. So using that, you can calculate omega as 2 pi n, or 2 pi into n is 4. Therefore, 8 pi radians per second is the angular velocity of the disk. Next, the moment of inertia of the circular disk about the given axis. In this case, the axis is passing through the center and perpendicular to its plane. So therefore, I is equal to mr square by 2, which is equal to m is 10, r is 0.05. Therefore, 10 into 0.05 whole square divided by 2. If you calculate it, you will get the answer as 0.0125 kg meter square. That is the moment of inertia. Next, the kinetic energy of the disk about the axis of rotation is given by E is equal to I omega square by 2. I is 0.0125 into omega is 8 pi, that is 8 into 3.142 whole square divided by 2. If you calculate it, you will get the answer as 3.949 joules. So which you can write nearly 3.95 joules. The fifth problem, a thin uniform bar of length 1.2 meter is made to oscillate about an axis through its end. Find the period of oscillation. The length of the bar is given as 1.2 meter. Let us take it as capital L, which is not mentioned here. Distance between the axis of suspension and the center of gravity, which is equal to half of the total length, because the center of suspension or the axis of suspension is at one end and the center of gravity will be there exactly at the center. So therefore, L is equal to capital L by 2, which is equal to 0.6 meter. And the moment of inertia of a thin bar of length L and mass m about an axis through its end is equal to ml square divided by 3. So we have calculated this while estimating the moment of inertia of various objects. So I is equal to ml square divided by 3. Next, the period of oscillation of a compound pendulum is given by t is equal to 2 pi into square root of I divided by mgl, where I is moment of inertia about the given axis, m is mass of the object or mass of the bar, g is acceleration due to gravity, and L is the distance between the axis of suspension and the center of gravity. So therefore 2 pi into square root of I is equal to ml square by 3, and mg into small l is nothing but capital L by 2. So simplifying it, you will get the time period t as 2 pi into square root of 2l divided by 3g. T is equal to 2 into pi is 3.142 into square root of 2 into small l is 0.6 divided by 3 into 9.8 equal to 1.795 seconds. So if you calculate it using a calculator, you will get the answer as 1.795 seconds. Next, a rectangular lamina has a mass of 10 kg, length 1 meter and breadth 0.5 meter. Find the moment of inertia and radius of gyration of the lamina about an axis through its center and perpendicular to its plane. So the data given here is mass m is equal to 10 kg, length of the lamina L is equal to 1 meter and breadth of the lamina B is equal to 0.5 meter. Therefore, the moment of inertia about an axis through its center and perpendicular to its plane for an object like rectangular lamina, it is given by m into L square plus B square all divided by 12. Here m is 10 and L is 1 meter and B breadth is 0.5 meter. So substitute that and simplify it, you will get the moment of inertia as 1.042 kg meter square. Here all the data is given in SI units, so therefore the final answer will also be in SI units, 1.042 kg meter square. And then the radius of gyration is given by k is equal to, you need to compare the equation of moment of inertia with the standard formula, that is mk square. If you compare it, you will get the radius of gyration k is equal to L square plus B square whole power half divided by square root of 12, which can be written as 2 root 3. Now substituting the values of L and B here, k is equal to 1 square, that is L square, plus B square, that is 0.5 whole square whole power half divided by 2 root 3. If you simplify it, you will get k as 0.323 meter. So that is the radius of gyration of a rectangular lamina about an axis passing through its center and perpendicular to its plane. So next, the seventh problem. A rectangular lamina has a mass of 2 kg, length 10 centimeter and breadth 5 centimeter. Verify the perpendicular axis theorem. So here the given object is rectangular lamina and you are supposed to verify the perpendicular axis theorem. For that, you need to imagine two axes or two mutually perpendicular axes in the plane of the lamina, and then the third axis which is passing through the intersection of these two axes and perpendicular to the plane. So the data given here is m is equal to 2 kg, length is equal to 10 centimeter. If you convert that into meter, you will get it as 0.1 meter. Similarly, the breadth is given as 5 centimeter. In meters, it can be written as 0.05 meter. So therefore, the moment of inertia about an axis through its center and perpendicular to its length first is given by Iy is equal to ml square by 12. Here m is 2, L is 0.1. Substitute and simplify it. You will get the answer as 0.00167 or 1.6 into 67 into 10 raised to minus 3 kg meter square. Next, the moment of inertia about an axis through its center and perpendicular to its breadth is given by Ix is equal to mv square by 12. Here B is 0.05 meter and m is 2. Therefore, substitute that. You will get 2 into 0.05 whole square whole divided by 12, which is equal to 0.0004167 kg meter square. Or else it can be written as by shifting the decimal point to 3 by 3 decimal places, you will get 0.4167 into 10 power minus 3 kg meter square. Next, the moment of inertia of the same lamina about an axis through its center and perpendicular to its plane. So this particular axis what we are considering is perpendicular to both the axes which are there in the plane of the lamina. So the moment of inertia Z is given by m into L square plus B square divided by 12. Here m is 2 and L is 0.1 and B is 0.05. Substitute it and simplify. You will get the answer as 0.00208 kg meter square or 2.08 into 10 raised to minus 3 kg meter square. So now we have moment of inertia about two perpendicular axes in the plane of the lamina. They are Ix and Iy. Add these two, Ix plus Iy is equal to 1.67 into 10 raised to minus 3 plus 0.416 into 10 raised to minus 3. Therefore, if you add these two together, you will get the answer as 2.08 into 10 power minus 3 kg per kg meter square. And we have calculated the moment of inertia about the z axis, which is perpendicular to the plane and passing through the intersection of these two axes, as 2.08 into 10 raised to minus 3 kg meter square. So from this it is very clear that Ix plus Iy is equal to Iz. So therefore the perpendicular axis theorem is verified. So I hope you have understood whatever the problems we have discussed till now. If you come across any other numerical problem, you can comment it in the comment section. I will post the answer in the next session. Thank you.